A big part of what makes an explosion really impactful and realistic is the shockwave element. So if you take a look at this finished and composited explosion shot here, you can see we have this kind of like dusty, smoky layer along the terrain here that just really emphasizes the power and impact of the explosion. If you saw this explosion shot without that shockwave, it wouldn't be nearly as effective. And next week we're going to get into these, combustible pyro effects like the explosion and the fire. But since we're talking about these density-based volumetric sims this week, like the destruction dust, it's also fitting to discuss the shockwave this week as well. So of course, you can wait until you do the explosion to do the shockwave. Typically, in production, we would do the explosion first and then the shockwave after that. But for the purposes of our learning here, you can feel free to work on this shockwave first if you would like. And sometimes in a production environment, you will get some previs animation for where these effects events happen. So for example, the animation department might put in just a noisy expanding sphere to indicate where the explosions are going to be and how they're timed and such. So you can feel free to add in your own, previs type animation if you want to do this shockwave before actually having the explosion available. So let's go ahead and start setting up the area of interest for this shockwave. So I've set up a geometry object here for that shockwave setup. And let's go ahead and object merge in the terrain. So I'll point that object merge to object / environment and out env low res. It's up to you if you want to use the low res or the high res for this. Either of them should work just fine. And let's also create an object merge for the creature as well. So I'll point that to object, creature ground, and render creature jolt. And we can merge both of those together just for display purposes. And just to make this a little bit nicer in the viewport, I'm going to go grab the colored version of this creature mesh instead. So I'll just go to our object merge for that creature and jump over to that. And then we have this colored version that we're using for display purposes here. And let's just add a null to reference that. This will be out creature jolt. Then let's just go back to our shockwave and update this object merge for that creature. It's a little bit visually nicer. And now we can carve out the area of interest in this terrain here. So let's drop in a bound and connect that to the creature. Perhaps template display that, and then drop in a Boolean intersect. Connect the environment to the first input of that Boolean intersect, the bound into the second, and we can just treat this environment as a surface instead of a solid object. So under set A, set it to treat as surface, and then display that. And you can see this is just carving out the area that's near the creature here. And we're going to be using this to do a few things. We're generating volumetric sources from this. We're going to be creating a collider object based on this as well. And we don't want this to change on every single frame. That can make things take a lot longer to process and cook geometry unnecessarily. I'm sure you've noticed a few times before me harping on this time-dependent network thing that you have to watch out for. So always try to avoid reevaluating your networks on every frame wherever you can avoid it. So let's drop in a time shift just before that bound and Control-Shift-Click to get rid of the expression on the frame. And I'm just going to set that to frame 80, which is about the frame at which our explosion happens. So you can see that little clock icon went away and this is no longer time dependent. And currently we're only trimming the terrain very close to the creature here. And we're going to want to source our shockwave volumes from a larger area and collide with a larger area as well. Now let's template display the bound, solid template our time shifted creature. And then on this bound, let's expand the padding a bit to include a wider area. So this looks like it should be a big enough region for that shockwave sim. And now let's just drop in a null after our Boolean intersect here. I'll call this env trim. And then to create the volumetric source, let's start by creating a circle, and I'll set the primitive type to NURBS curve, and let's display that. Let's just put our template display on the environment and the creature. And just to keep our display nice and efficient, I'm going to change this merge to point to the time shifted and frozen version of that creature jolt, just so this isn't loading up cache frames just to display things. And then let's just set the center position of that circle to approximately where that creature is. And then set this to the ZX plane so that that's a flat curve, and we'll make this an open arc instead. And then adjust the arc angles so that we don't get an entire circle out of this curve here. I want to get something that's a bit more than a half circle here, because I want this shockwave to kind of spread out and not just in a half circle in front of this creature's mouth here, but I want it to sort of push around the sides of the creature as well. So a bit more than a half circle should work well for this. And now let's drop in a transform SOP to position this a bit better. Connect that to our circle here. We'll use our usual centroid transform preset. Let's rotate this to point the correct direction here, and then move this into place just under the mouth of this creature. Let's go into wireframe mode to get this just right here. And that might be a little bit hard to see in this wireframe screen capture here, but that positioning should work pretty well for us. And now we can start animating this circle to block out the shockwave. But before I start animating this transform here, I'm actually going to change this center point of that pivot to, instead of being the centroid of our input, I'll channel reference that to the center of this circle here. Because this is a semicircle, this actual center point parameter here is going to be the true center of that circle better than the centroid of the geometry is. So I'll copy that center parameter back in our transform. I'll paste in the relative reference there. And now we can go ahead and start animating that curve to block in the shape and progression of that shockwave. And now, after keyframing some expansion on this curve here to block in this shockwave motion, let's also ray this onto the surface of the terrain. So I'll drop in a ray SOP, connect the second input of the ray SOP to our trimmed environment. First input will be the curve that we've just animated. And for the direction, I'm going to set an explicit vector, and I'll get rid of the expression on this, Control-Shift-click that, set the ray direction to -1, and part of our curve here is already underneath the terrain, so that's not going to be rayed properly. So oftentimes if you're doing a ray in a specific direction, you might want to just initially transform it in the opposite direction just to make sure that everything is on the correct side of that geometry. So I'll drop in another transform SOP just before this ray here, and I'll push our curve up quite a bit in Y. I'll just transform that up 20 units, so that's guaranteed to be above the terrain there. And this is still a little bit hard to see. It looks like this curve is still going underneath our geometry here. And that's likely because this is a NURBS curve, and it's only going to use a few points to define that smooth curve. So if we just display the curve itself without our template geometry, and we look at the points here, you can see this is only using a handful of points to define this NURBS curve. But this is still fine for now. Let's bring back our reference geometry. We're going to resample this curve a little bit later for some more resolution. So I'm not too worried about this being perfectly outside the geometry right now. But if you want to, you could temporarily set a negative lift direction on the ray stop, just so that we can see the curve a little bit better as we're animating it here. And let's do a flipbook to see what this looks like so far. Now, if you play back this animation, we have a nice rapid expansion on this, but this animation stops too abruptly. So we want to have a nice ease out fall off to this animation curve so that it just resolves a little bit more slowly at the end there. So let's go back to our transform that we're using to animate this. And oftentimes it's a little bit annoying for Houdini to display everything that you select in the viewport. Like you can see just by selecting the transform stop, I'm seeing that layered in with the node that I actually have displayed. So I often like to turn off that option. So if you go to this icon here, right click that, you can change this from show current operator to show display operator. And this can be particularly helpful if you're working with really heavy networks that are forcing things to cook just from selecting nodes. It can be easier to work when you change that option in some cases. So yes, back on this transform that we're using to do our animation, and I suppose I'll rename these for clarity. Call that one animation. I'll call this transform Y offset. And then we can shift click these parameters to bring them up in the animation editor. Space G will show the entire curve here. And it looks like we do have a relatively flat curve at the end of our animation here. You could select these curves, and instead of using Bezier, you could change this to ease out instead. And this will force a nice slowdown at the end of that animation. However, that can potentially cause a little bit of disconnect with the slopes on these curves here if you're using Bezier for one portion and the ease out for the other portion. That's not necessarily problematic, especially for fast animations like this one. So it's up to you if you want to just use an ease out like that, or if we undo that and go back to the Bezier handles, then we can just adjust these handles manually as well. So if we drag this handle out like so, that's going to force a slope that's kind of similar to what we saw with the ease out setting. And in this particular case, I don't feel like we have to be super picky about getting this fall off curve exactly right, as long as we get a nice little slowdown at the end of the animation here. That's the key part. So something like this should work reasonably well. And most of this animation is coming from this scale on the X and Z axes. The uniform scale I'm using to just help control the overall size of this, but that's really only controlling the size for the first few frames here, so it's not quite as crucial. I only have uniform scale keyframes on frames 80 through 82, so I'm not going to worry too much about the curves on that. And similarly with the translate animation, I'm really only nudging this a few units in the first few frames of this because I'm super picky about this stuff. So feel free to adjust those curves as well, but it's really the main scale X and Z curves that are doing most of the work here. Now let's see what this looks like with the new fall off. And now if we check the adjusted animation, you can see there's a little bit more fall off to the end of this curve animation here. And it's kind of a subtle difference, but it does help a bit just to slow down the expansion a little bit toward the end there. And I really am just animating this over the course of about 7 frames here. And this is going to help drive the velocity of the simulation and control how quickly the shockwave density spreads. And once this curve animation stops, we are still going to get some expansion and motion carrying over into the simulation, so you don't have to animate your shockwave curve for the entire length of the shockwave's behavior. You just have to animate it for this initial primary emission here, long enough for the sim to pick up this velocity and behavior and take over from there. So now we can noise up this animation a little bit. I'll drop in an attribute noise just after that transform that's doing the animation. Crank up the amplitude a little bit. set the range to 0 centered, and the element size, I'll turn this up to a value of 10. And right now we're only getting a color noise on here, but we want to noise up the position, so change the attribute name to P. And I'm barely seeing any noise in this curve because, as I already pointed out, this is a very low resolution NURBS curve. So if we're noising up the points, we only really have a few points on that curve. So on the circle here, I'm going to go to the divisions, turn that up to 1000, which will allow us to have enough resolution for our noise to mean something, and that also gives us a better ray onto the surface of the terrain here. So now that we have this slightly more interesting and noised up curve here, let's go ahead and add some velocity to this. So after the ray stop, I'll just add in a trail, connect that up, and on the trail I'll set this to compute velocity, rename that for clarity. And now I'm going to build a surface from this curve position to where it was on the previous frame. So I'll drop in another trail stop, but I'm going to leave this one on its default settings, which will create a copy of the curve at the previous frame position. And then we can use an add stop to create a polygonal surface between them. So I'll drop in that add, and then go to polygons by group, and then under the add option, we'll set this to by attribute. But we don't currently have an ID attribute that this can use to match up the points. So I'm going to go back to just after we've created the curve here and drop in an enumerate stop, set this to points, drop that just after the circle, and this will add some IDs to all those points on this attribute called index. And then back on our add stop here, under the attribute name, I'll just type in index. And now you can see it's building this surface in between the current frame position and the previous frame. And we can also display our velocity to make sure that's working correctly, and that looks all good. So this is starting to look like a good source for a shockwave. However, we're going to need a lot more resolution on here. So after the add stop, I'm going to drop in a resample and display that. Let's turn off our point trails, check our resolution by turning on point display here. And this actually looks like a decent amount of resolution with the default amount of resampling here. And because these are just straight lines, let's once again noise this up a bit more. So drop in another attribute noise, set the name to P, range values will be 0 centered, and let's display that. Maybe turn up the element size a bit. And if you want to get really picky about this noise per axis, we could set different amplitudes for each axis here. So for example, if we only want to noise this up on the X and Z axes, we could perhaps turn the Y amplitude all the way down to 0, since we're going to be raying this onto the terrain once again anyway. So after this extra bit of noise breakup on the source here, let's push this right back onto the terrain once again. So just like before, I'm going to first transform this upward a bit, call this Y offset, and translate this up about 5 units this time. The amount of Y translation doesn't really matter as long as it's enough to safely keep our geometry out of intersection with the terrain. And then drop in another ray stop, connect our source to that. Second input of the ray will be our trimmed environment once again. Display that, and as before, the direction is going to be a vector. Get rid of this expression in there and set the vector to -1 in Y. And we do want our source to kind of stick to the terrain pretty well, but I don't necessarily want it to be perfectly flat onto the terrain everywhere. So we can use a bit more noise to kind of push this up in the Y direction. So dropping a new attribute noise after the ray stop and displaying that, set the attribute name to P. And for this one, I'm going to leave the range values as positive because I'm just trying to push the points upwards in Y to push it off the terrain in some areas. And since I just want to push this upwards off of the terrain, we don't really want to add the noise in the X and Z directions. So click this XYZ button, and I'll set X and Z amplitudes to 0. And at this point, you could either use the global amplitude here to turn that up or down, and you can also use the Y amplitude directly as well. It's up to you. And right now, it's still kind of pushing this up everywhere. So we can have a bit more control over this and make that a little bit more patchy by turning on this Enable Remap Ramp option here. So by default, this is going to be a linear noise ramp from 0 to 1. So we can change this ramp to have less amplitude for a larger portion of our range here. And this just helps to keep those lower noise values closer to 0. And it's really kind of a subtle difference that you don't necessarily have to obsess over if you don't want to. But I think this remap ramp helps to keep this source a little bit more connected to the ground than it would be otherwise. So if you take a look at where these points meet the ground, without that ramp, you can see that all of these points are really getting pushed off of the surface quite a bit. And with that ramp in there, now we have our source points nicely connected to the terrain, and we still have this spiky detail that's offsetting it from the surface in places. And right now this noise is looking a bit spiky here. I think we can go with a larger element size for this. We'll try turning that element size up to 5. So this gives us some nicer shapes on there. The source still conforms nicely to the terrain, just with some extra shapely undulations in there. And sometimes when I apply noises like this, I like to do a fresh resample afterwards, just in case some areas get a bit stretched out and sparse. An extra resample can help to ensure as much resolution as we want in there. And because these are still forming these pretty clear lines in our geometry here, I'm going to jitter that as well. So drop in a point jitter. And that's a bit crazy and extreme by default here. So let's try turning that down. I'll try a scale of 0.5. And this is still a bit crazy, but this can actually still work quite well for our density volume source. And you could potentially do another resample after jittering the points like this, but I think this is actually going to work all right as it is. So I'm not going to obsess too much about resampling at every stage of our noise here. And now that we have this nice source spreading across the terrain here, we can go ahead and convert this to a volume that we'll feed into our sim. And to generate that source volume, I'm going to first set the density values on these points. And we're going to use an attribute noise to set these density values. And you could just set the density attribute directly, but sometimes I like to, instead of density, set this to the color so that I can see it a bit more easily in the viewport. And then I can rename that color to density afterwards. And right now we have a proper RGB color on all of these points assigned in this noise here, but we can make this a black and white color instead by changing the vector to float. And I actually think this element size is working pretty well for our density scale. It seems like a reasonable amount of splotchiness to our density values, but I don't want the density values to go all the way down to 0. So on this remap ramp, let's enable that again. And we don't need to add any points to this, but if you select the very first point, instead of letting these values range from 0 to 1, we can increase the lower value here, which is effectively the minimum density, and I'll turn that up a bit. So this still gives us some nice density coverage on this entire source, but it'll just break up those values a little bit, so it's not just a density of 1 everywhere. And now that we have the density values set on the color, let's rename that attribute to density. So drop in an attribute rename, and under the point tab, change the attribute from CD to density. and then drop in a volume rasterize attributes. And we want to rasterize both density and velocity. The voxel size, I'm going to set the same as the pyro solver once we add that, but I'll just leave it on its defaults for now. Or perhaps I'll just turn this up a bit just in case it turns out very high res at the current voxel size, and display this. And this currently looks pretty terrible, so we can try turning on the lighting in our scene so that we can see the volume a bit better, but this isn't looking very good either. So let's add a standard Houdini light to help illuminate this volume here. So I'll pin the viewport to our Shockwave section here, and then go up to the object context, and let's go up to where our rendering setups are. And I'll just add in a new light here. Let's create a sunlight. Perhaps dial that down a bit. Maybe turn down the shadow intensity a little bit as well. And you can rotate this to your liking. So this is working a bit better like this. This looks a little bit weird here. I'm just going to assume that's some sort of a strange viewport glitch and ignore that for now. And this is currently looking quite blobby, and I want this to be a bit more defined than this. So on the particle scale, let's turn this down to create a finer source volume. And if you have a p-scale attribute on your source points, it will use that to determine the particle scale here, but with the way that we've set up our source, we don't have a p-scale attribute on here, so it's kind of up to us to set a particle scale that makes sense with the density of the points that we've input here. So I think that a particle scale just below 0.3 is looking pretty good. This looks nicely detailed, and we can get some more interesting details out of the actual simulation shaping and parameters. But just for our Shockwave source, I think this is going to work quite well. Now at this point, it's up to you if you want to cache out this source so that it's not computing this on every frame as you're simulating it. And sometimes when you're doing volumetric sims, the creation of your source like this can be a bit slow, and it often is a very good idea to cache out these sources. In this particular case, I'm not too worried about it because this does look like it's creating this pretty fast. But if you want to, you could certainly drop in a file cache and write that to disk just to be safe. And we decided that the start frame of our explosion was going to be frame 81. So let's drop in a pyro solver, set the start frame to 81. And for the resolution of this pyro solver, I'm going to start by setting it to what we've already set on our density source here, which is 0.15 on that voxel size. We can of course tweak this for more or less resolution if necessary. And let's connect our source to that. And right now, our source is only changing from frame 81 up through 87. At frame 87, it's just going to hold this ring at the edge of the shockwave here, and we don't want it to continuously source from this little ring source there. So oftentimes, to prevent the network from cooking and prevent us from adding more sourcing when we don't need it anymore, I will drop in a switch just before the pyro solver. And then on this select input, I'll say at frame is greater than 87, drop in a null and connect it to that switch as well. So if you display that, you can see that once we get above frame 87 here, it's going to just switch over to adding nothing extra to the sim. And now to add collisions, we can wire those into the second input of our pyro solver, and this can create your collision just from passing in geometry, or you can tell it that you're passing in a collision SDF with volume velocity, and this gives you a bit more control over exactly how those collision volumes are constructed. So if you want to be lazy, you can just try passing in some collision geometry, but generally I like to build my colliders so I know exactly what they're doing. So on our trimmed environment here, let's display that. And right now this is just a planar surface geometry. So to create a nice collision volume for this, let's give this some thickness. So I'll drop in an extrude volume, connect that to our environment trim, and it looks like the default settings of our extrude volume should work just fine. And now let's drop in a collision source on this. And the first output of the collision source is going to be geometry, and the second output is going to be a collision volume. So it's that second output with the volume that we want. So let's go over to the volume settings here. And for the voxel size, I often like to reference this to the actual Pyro Solver settings. So on the Pyro Solver, let's copy the voxel size here. So copy that parameter, and we can actually use that for our density input volumes as well. So on this volume rasterize attributes, I'll paste in a relative reference there so that this matches any changes we make to our Pyro Solver resolution. And then on our collision settings over here, we can actually often get away with less resolution on our collider than we have in our actual simulation. So let's paste in the relative reference there so that this will match the Pyro Solver resolution. But if you want to make this a little bit faster to generate, you could potentially add a multiplier to that resolution here. So I think it's fine if we just want to double the voxel size for our collider. And let's drop in that null, connect it to the second output of our collision source and display that. And you can see that even with this set to double the voxel size of the Pyro Solver, we're still getting quite a lot of detail in this collider here. And this is still the low-res version of the environment, so if you want, you can certainly change our object merge here that's bringing in the environment and swap in the high-res geometry instead, but I'm just going to try leaving this on the low-res geometry because I think it'll be close enough for the purposes of our Shockwave. So now our collider is all set up. We don't currently have any collision velocity, but that doesn't really matter because this is just a static terrain. So let's connect this collider to our Pyro Solver's second input, and then go back to the start frame of our simulation, display that Pyro Solver, and template display our reference geometry, turn on the viewport lighting once again, and then let's see what this Shockwave sim looks like now. So checking out the results of the first simulation, this is looking like a promising start. However, everything is being blown apart too quickly by the velocity, and it's all dissipating very quickly as well, and we definitely need to tone this down quite a bit in a few different ways. It's also looking very, very thick and dense here, and I want the Shockwave to look a bit lighter and not just this heavy, thick cloud like this. I mean, perhaps a heavy, thick Shockwave cloud can look cool, but for this shot, that's not quite what I was looking for. So on the Look tab, we can lower the density scale here. Let's go to a sim frame where we can see that a bit better. So on frame 83, you can see that's looking quite dense. Lowering that density scale to about 40% is looking quite a bit nicer. And another thing I like to do is ramp down the amount of density that's being added after the start frame. So right now we're adding 100% of the density in the input on every frame. So I like to use an expression in here. So I'll do a fit function based on the current frame. So I'll start this ramp down at frame 82 so that we get a couple frames of full density emission, and then have it completely turned off by frame 88 and ramp that density scale from 1 down to 0. We can remove this burn and flame source here. That's not necessary for a Shockwave. And the temperature here is going to affect buoyancy, and in order for buoyancy to work properly, we need to add some temperature in here. Currently we're not sourcing any temperature, and sometimes I will actually use the density as the source volume here and add that into the temperature field. But since I actually like this initial behavior, I'm going to leave this alone at the moment. And I'll only start playing around with this if we really need to adjust the buoyancy of the sim. And then for the velocity sourcing, we're actually getting much more velocity influence than we really need here. And you can kind of see a lot of these very spherical shapes appearing like this. And this is one of the classic problems with volumetric sims. And you'll be fighting these kind of like spherical mushroom shapes quite a bit when you're doing simulations that have a lot of high velocity input. And there are a few ways that you can address that. One of the easiest ways is to simply reduce the amount of velocity that you're adding in here. And I already felt like this simulation was completely blowing away all of this dust far too quickly. I want this shockwave dust to kind of linger around on the terrain here and just get a bit of a push away from that explosion. So I'm going to try setting that scale to 0.1, so we only get 10% of the velocity added to the sim. And if we go to the Export tab, this probably won't make much difference, but on the output from our Pyro solver, all we really care about is density and velocity. So we can remove the temperature and flame and color exports if you want. Under the Solving tab, this is where some of the most important settings live. Under the Shape tab here, we can set our dissipation and turbulence and disturbance. For a dusty, smoky sim like this, we generally don't really need to deal with shredding at all. And we're going to talk about shredding a bit more once we get into the fire simulation, but it's not really necessary for our shockwave here. We are going to need to turn down the dissipation because I really want this shockwave dust to kind of linger in the air for a while after the initial emission. So I'll turn that down quite low to 0.01. Let's turn on the disturbance and crank that up quite a bit. And then go to the Disturbance tab here, and it's very important to set a reasonable block size for this. And we have two different options for our disturbance here. And the continuous option doesn't actually use the block size. This will generate a random vector per voxel to break up that velocity field at the smallest representable level given our voxel resolution. Whereas the block-based disturbance will add a noise of explicit sizes to break up the velocity field. So it's up to you if you want to play around with that, or just do explicit block-based disturbance here. And to help determine the base block size for this disturbance detail, sometimes I like to add in a reference box. And for the box position, maybe I'll grab that from the circle's position here. I'll copy that center position parameter, and on the box, I'll paste that in there as well. Paste the relative reference and that center parameter, and let's display that box. And if we zoom in here, this box with a size of 1 can give you a rough idea of the size of the disturbance detail that's going to be added with a block size of 1. So this could work reasonably well to add some larger scale disturbance like this, but I generally like to go a little bit finer with my disturbance than that. So I'm going to try probably half that size. Let's try a scale of 0.5. And this disturbance is essentially going to break up the velocity for some more detail. And a velocity breakup detail size of 0.5 like this seems like a good starting point. So back on the Pyro solver, I'll set the base block size to 5. And I'm not going to go over every single parameter here and describe what each one of those does when you can easily check the docs for some more information on these. But a couple key ones to point out are the max octaves here. So in block-based disturbance mode here, it's not only going to add in a disturbance size that we've set here of 0.5, it'll add up to a couple layers more of smaller disturbance as specified with the max octaves here. And the roughness determines how much amplitude each successive layer of disturbance has. And this lacunarity determines the relationships of the size of the block size with each successive layer. but I think all of these defaults are going to be fine as they are here, at least for the next version of our sim. So now let's also enable the turbulence, crank up the turbulence amount a bit as well, and on the turbulence tab, similar to the disturbance, we need to set a size for this, and often with simulations like this, I like to use the disturbance for the really fine detail, but the turbulence for the larger scale swirls. So I'm going to try a swirl size of 2, and I'll leave everything else at default for now. So as for our shape settings, I think this all looks good to run a new simulation. Just to take a look at a couple other things in here, we don't need to worry about the flame settings for our Shockwave. Don't really need to deal with the color either. Under the Advanced tab, I'm going to leave all this stuff alone. However, sometimes for fast-moving simulations like this, you may need to increase the padding on your resize, or you might be hitting the bounds of the simulation because it's expanding too fast for the resize to account for it. And this Shockwave does move and expand pretty quick, so it's very possible you may need to increase this padding here. Over on the Simulation tab, you can speed up or slow down the overall behavior of the sim with your time scale. For something like a Shockwave, we probably don't need to mess around with viscosity or anything else. These buoyancy settings can be quite important, but at this point I'm kind of happy with how the simulation is behaving in terms of buoyancy, so I'll leave that stuff alone for now. And let's rewind our sim and see how this looks with the updates applied. And now reviewing our updated simulation, this is looking pretty good. And of course, it would be much easier to dial this in to get the behavior just right if we had the explosion in there as reference. As I said earlier, typically you wouldn't be doing the shockwave before you do the explosion, but since we're learning here, I wanted to teach you these density volumetric simulations first before we get into all of that combustion type stuff. And yeah, this is all looking pretty good. I'm pretty happy with this. There are some issues with perhaps this area on the far side of our simulation here. This is getting a bit sparse and we're seeing a couple bands of density here. So you might want to perhaps, thicken up the source a little bit in this region here. And you can certainly, finesse certain parts of your simulation source like that. But I'm not going to worry about it too much. That will probably be covered up by the explosion anyway right there. And it's also a good idea to start rendering your results before you really fine-tune a lot of these little details. Because with volumetric effects in particular, they're really dependent on how they're rendered. And in the viewport we are seeing some little voxel grid artifacts and such. Some of this stuff might not be so apparent in the render. And you can add in additional microsolvers on top of your standard shape settings on the Pyro solver here. Under the solving tab in shape, we have our standard disturbance and turbulence here. But if you have something you like and you don't really want to change this, you can dive into the Pyro solver here and then start adding in additional microsolvers. Like for example, if you wanted to add another gas disturbance, and then maybe a gas blur, and a gas diffuse. And we can merge all of these microsolvers together. Just drop in a merge, connect all of those, add that to our force output. And this allows you to just really build up some extra additional fine-tuned controls with all of the DOPS microsolvers that are available to you here. For this, I really don't think we need it, because our sim is looking pretty good, and I'm not really seeing any problematic voxelization artifacts, and I think this is in good shape to start rendering it. So let's jump out of our Pyro solver here, add in a file cache, connect that up to our Pyro solver. I'll set the start and end to go from frame 80 to 240, create a new Shockwave sim directory, call it shocksim.$f3.bgo.sc. Accept that, turn on load from disk, and then hit Save to Disk to save out this entire frame range. And now after simulating the entire frame range and flipbooking the results, we have a shot that looks like this. And this is looking quite cool. Of course, we may want to really get in there and finesse things once we see the explosion in there with it, because we may want to adjust things in context. But overall, this is looking quite good, and I'm happy with this, so we can go ahead and start rendering that.